Right now, as you watch this, our entire galaxy, every star, every planet, every atom of everything you have ever touched or loved or known, is being dragged through space at 2 million kilometers per hour. Not drifting, not floating, being pulled towards something, and we cannot see what it is. In the 1970s, a group of astronomers were doing something routine, mapping the motion of galaxies across the universe. They expected to find the usual pattern: galaxies drifting apart from each other, carried by the expansion of the universe following the Big Bang. What they found instead stopped them cold. Galaxies weren't just drifting, they were being pulled. Thousands of them, including our own Milky Way, all moving in the same direction toward the same point in space. A point nobody had been looking at. A point that, as far as anyone could tell, contained nothing special at all. The astronomers called the source of this pull the Great Attractor, and the name alone should tell you everything about how unsettling this discovery was. Not the Great Cluster, not the Great Mass, the Great Attractor. Something out there is attracting everything around it, on a scale that defies imagination. Here's the scale we're talking about. The Great Attractor sits approximately 250 million light-years away from Earth. 1 light-year is nearly 10 trillion kilometers, 250 million of them. And the gravitational influence of whatever sits at that location extends across a region of space so vast it contains thousands of entire galaxies, all of them falling inward toward the same invisible point. Our Milky Way, with its 400 billion stars, is just one of those galaxies being pulled along. But here is where it gets truly strange. When astronomers tried to look directly at the Great Attractor, to point their telescopes at this enormous gravitational source and simply observe what was there, they ran into a problem nobody had anticipated. It's hidden. The Great Attractor sits behind the densest part of our own Milky Way galaxy. Our galaxy is so thick with stars, gas, and dust in that direction that it blocks almost all the light coming from beyond it. Astronomers call this region the Zone of Avoidance, a blind spot in our own cosmic map, a direction we essentially cannot see. For decades, the most powerful gravitational source ever detected was sitting right there, and we couldn't look at it directly. We knew something enormous was pulling us. We just couldn't see what. It wasn't until the 1990s, when X-ray and radio telescopes were able to partially pierce through the dust, that we began to get our first glimpses. What they found was a massive concentration of galaxy clusters. Hundreds of galaxies clumped together in a region astronomers named the Norma Cluster. Dense, enormous, gravitationally dominant. But here is where the mystery deepened instead of resolving. The Norma Cluster, as massive as it is, still wasn't enough. The mathematics didn't add up. The gravitational pull we were measuring was stronger, far stronger, than anything the Norma Cluster alone could explain. Something else was there, something even bigger. Further away, hiding behind the hiding place. Over the following decades, as telescope technology advanced, the true picture began to emerge, and it was bigger than anyone had imagined. Our Milky Way is not just being pulled by the Great Attractor. We are part of something called the Laniakea supercluster, a structure so large it contains over 100,000 galaxies, stretches 520 million light-years across, and has the combined mass of 100 million billion suns. Our galaxy sits on its outer edge, like a single grain of sand on the rim of a continent, and Laniakea itself, all 520 million light-years of it, is falling toward the Great Attractor. But even that isn't the end of the story. Behind the Great Attractor, at an even greater distance, lies the Shapley supercluster, the most massive known concentration of matter in the observable universe. A structure so vast it may be influencing the motion of galaxies across 1 billion light-years of space. Some models now suggest the Shapley supercluster is the true engine behind the pull we feel, with the Great Attractor simply being one dramatic waypoint on a much longer gravitational journey. We are not falling into a hole, we are falling down a cosmic slope, pulled from one gravitational giant to the next, across distances so vast that the motion is completely invisible on any human timescale. So what does this mean for us? In the short term, nothing. The distances are so incomprehensibly vast that the motion makes no practical difference on any human timescale. We won't feel it. We won't notice it. Life on Earth continues completely undisturbed. But in the long term, the Great Attractor reveals something deeply unsettling about the fate of our universe. The universe is not just expanding, it is accelerating. Every year, the space between galaxies grows faster, and eventually, that acceleration will overpower even the gravitational grip of the Great Attractor and the Shapley supercluster combined. Our galaxy will be torn away, carried beyond the gravitational reach of these enormous structures forever. The Laniakea supercluster will dissolve. The Great Attractor will cease to attract anything at all. And as the universe continues to expand and accelerate, everything beyond our local group of galaxies will eventually cross the cosmic horizon, moving away from us faster than light, disappearing from our observable universe forever. One day, the night sky will be nearly empty, and the Great Attractor, this enormous, mysterious, invisible force that has been pulling us for billions of years, will simply be gone, not destroyed, just unreachable, as if it never existed at all. But the Great Attractor isn't the only mystery hiding in the direction we can't see. In 2022, astronomers detected something in deep space that no known law of physics can explain. A signal repeating every 18 minutes, like clockwork, from a source we've never seen before. Some scientists think it's a new type of star. Others aren't so sure. In the next video, I'll show you what they found. Subscribe, because this one will change how you think about what's out there.